Hey, thanks for joining me. Today we're going to test out a relatively new power station from Opus called the Mega 1. It's not brand new, but it's been out for a couple of months. And this is the smallest member of the Mega series of power stations. And it comes in at a rated 1,024 watt hours of capacity. And it has a rated 2,000 continuous watts of AC out of the AC inverter. And interestingly, like its larger siblings, this Mega 1 does have battery expansion options up to just over 5 kilowatt hours, which is pretty cool for something this size, and especially considering a $499 price point that this thing is currently selling at, which is less than, if you're doing the math, less than 50 cents per watt hour. And by the way, those B2 expansion battery modules not only have their own USB ports and 12 volt car socket outputs, but they also have a 12 volt 30 amp Anderson output connector and the ability to be independently charged via up to 2100 watts of solar, which means they're very capable DC power stations on their own, able to function completely independent of the main unit, whether it's a Mega 1, a Mega 2, or a Mega 3. And those B2 battery expansions are rated for 2,048 watt hours. So adding just one of those expansions to the Mega 1 will triple your overall battery capacity. But let's jump back in time and see what this thing comes with in the box, and then we'll get into more details on the specs during the course of testing, and we'll find out if there are any compromises that you might want to be aware of. All right, one user guide, and in the back, a warranty card. This has a 3-year warranty, by the way. Let's see what cables we've got. All right, we've got a car charging cable here with an Anderson connector on one end. We've got a solar cable, MC4 on one end, Anderson on the other, and a pretty heavy gauge AC charging cable. Now this does have sort of a non-standard pin connection on the plug side for the power station. So this isn't the same kind of cable you would typically see for a computer power supply. So just be aware of that. This is a little bit different. All right, here's the guy here. Take the little plastic off the display and let's power it up. 63% from the factory. All right, so let's just have a quick look around. There is no wireless phone charging on the top. There is a battery expansion port here on the side. Let's see, you've got 6 USB ports here. 4 of them are quick charge 18 watt 3.0 here, and 2 of them are PD 100 watt. So I would have actually liked to have seen this ratio reversed. I mean, it is 2024. I think I'd prefer to see 4 of the Type C's and maybe just 2 of the Type A's. Not a big deal, but yeah, that'd be my personal preference. And then over here, you've got a 12 volt 10 amp car socket output, and then a couple of DC 5521 12 volt 10 amp outputs as well. So this unit is a 2,000 watt continuous rated output for the inverter, the AC inverter, and it has 4 20 amp AC output plugs on the front. So that is outstanding. And the peak surge rating on that, I believe, is a whopping 4,500 watts. On this other side, looks like there's a little helpful tip card, just kind of suggesting that you charge the battery at least every 3 months to extend the battery life. It's got a little port door here that has an Anderson connector on the top, and that's where you plug in either the car charging or the solar charging. And this takes up to, I think, 800 watts of solar. Yes, this takes up to 800 watts of solar with an input range of between 12 and 80 volts DC. So that's a pretty good voltage range. So you can put a fair amount of panels in parallel to get up to that 800 watt solar input, and it maxes out at 13 amps total. So you've got your AC connector there, and then you got a little overload breaker reset. So that's about it. Nothing on the back. There are no area lights on this unit. Let's dive into the testing and find out what this thing is all about. All right, let's do an usable capacity discharge test on this Mega 1 through the AC inverter. This is a 2,000 watt AC inverter, as I mentioned, and it's got 1,024 rated watt hours. And we know we're going to lose some of that in the AC to DC conversion, plus whatever the BMS wants to reserve for the battery. We are charged at 100%. So let me go ahead and turn on the AC inverter. I think we'll use this port over here. Let's just check the voltage output. And we're getting a full 120 volts. So that's excellent. Let me go ahead and put it back to watts. And we are actually going to charge another power station with this. And I think we'll probably get up to 800 watt range. Looks like closer to 900 watts. All right, and we're gonna let this thing run all the way down until the BMS in this Mega 1 shuts us down. And we'll find out how many actual watt hours we actually get out of that 1024 rated watt hour. So check back in a little bit. And I can definitely hear the fan, so let's check the fan volume. So about 59 decibels. So this is not what I would call a super quiet power station. I would call this an average volume power station. So, all right, let's do a capacity test out of the DC port. So we've got the 12 volt, 10 amp car socket here, and then we've got a couple of DC 5521 ports here. And it does say 12 volt, 10 amp right there under the label. I'm not sure if that's 10 amps total out of all three ports, but let's find out. Because if we can, I'm gonna try to pull from the car socket and also the DC 5521. So let's get the car socket test going, because that's the way that I normally test these things on their own. So we got the DC turned on. We are showing 12.6 volts, and I'm gonna pull 10 amps, and we're gonna see how that goes. So that has not shut us off. I'm gonna plug the other tester into one of these 5521 ports. And I am showing 12.5 volts. Let me try dialing that up and see what I can get out of that other port and see if I can figure out where it's going to trip us. All right, so I got to about 145 watts and it cut us off with an E10 error. So I'm gonna go ahead and dial that back down. Restart the DC ports. I'm gonna restart the test here. I'm going to take this up just a little bit and see if I can get, we should be able to get to at least 120 watts. Let's see if I can get a little more than that. All right, so it looks like we're going to get to about 130 watts. So we'll come back after the BMS shuts us down due to a low state of charge. We'll add up the watt hours on both testers and find out what we actually got out of that rated 1020. So we're going to see if we can go ahead and hook up solar to kind of simulate what would happen if you ran this thing down overnight, and to see if it will automatically begin charging itself. Now this is rated for a maximum of 800 watts of solar input and up to 12 to 80 volts max. So no more than 80 volts. Now I need to put these in a 2S, 2P, or 2 series, 2 parallel arrangement, where I have two series pairs that I then connect with parallel branch connectors, which is what I've done. And that'll bring the voltage down to somewhere between 44 volts to 46 volts open circuit. And let's see, the maximum current from those panels is 11 amps. So I'm going to be doubling that since I've got those two strings in parallel. So that's going to be about 21 amps in order to get to that rated 800 watts of solar. However, this particular power station is capped at 14 amps. So I'm not going to be able to get the full 800 watts out of that particular configuration with those panels. And that's okay. But what I'm really interested to see is whether this will automatically charge by itself. So let me go ahead and plug this in. Back in, see if it wakes up. And now we are recharging. But as you see, we are now pulling in, around 50 watts, and that's going to continue to climb as the sun gets much better alignment. So this is only 1:16 in the afternoon, so not even 2 full hours, and we have fully recharged this thing from when we started it at 0 charge. So that's pretty impressive. This thing does charge very quickly. So solar charging test on this passes, except understanding that you have to manually plug in the cable if you let it run all the way to 0. I suspect that that's not the case if it just goes into standby. I may have to try to test that, but I do know that if it runs all the way down to 0 and you have that error code, it will not auto resume charging until you unplug and replug once the sun has come up. So find out how much noise there may or may not be coming out of this AC inverter. To do that, we're going to use our Craftsy Deal guitar amp here, no grounding pin. I currently have it for a baseline reading plugged into an extension cord here, going to my solar system that's powering the barn. It's pretty clean system, should give us a fair indication. It basically sounds the same as grid power. So let me go ahead and hold the mic up here. We'll power this up. We'll find out what it sounds like on basically the equivalent of grid power. All right, not too bad. As you heard, there's a pop and a little bit of a low hum. Now, I boosted that volume for you so you could hear it a little more clearly. I think I usually boost that by about 9 decibels. And I'm going to change the power over to the AC inverter on the Mega 1, and we are going to find out if it sounds any different or not from grid power. So let me go ahead and plug that in. I already have the inverter on. So yeah, so the inverter is on, and let's find out if it sounds any different. So at least for my ears, that sounds virtually identical. So pretty clean power output out of this AC inverter on the Mega 1. And yeah, I would say it definitely passes the inverter noise. One feature I do like to see on power stations that's probably only on maybe 15 or 20% of them is a mechanical switch to allow you to toggle between fast charging and slow charging via AC. And the reason you might not want to fast charge all the time is because the faster rate that you charge at consistently, the greater the stress on the battery cells. And so if you're not in a hurry, I don't recommend fast charging all the time. And this unit does have the capability of fast charging and slow charging, but it does it through a key combination rather than a single switch. So it's a little bit awkward, I have to admit, but basically you would have to, when you are not charging, so you have to have the AC unplugged, you then go into the IoT button or click the IoT button and the DC button at the same time, and you press and hold, and you'll see set. And then we have low and high. So if we want to do fast charging on high, then we press and hold the power button, and then the set will flash, and then it says success. All right, press the power button again, and that means that we have successfully set it to fast charging. So let's go ahead and see what that looks like. This should be under maximum conditions, about 1400 watts. I suspect we'll be a little bit lower than that here, but let's see where we end up. The maximum volume, by the way, that I heard on this when we were doing the load test, maybe it showed up in the time lapse, was about 65 decibels, which is not much louder than it is right now. So it looks like we're going to cap off at just a little over 1300 watts, and that's typical. All right, so that's fast charging. If we wanted to drop down maybe to 700 watts or slightly lower, again, we make sure it's first unplugged, hold the IoT and DC button down, and we have set. Now we have it set to low, so I'll press and hold power to lock that in, and we have success. So press and hold power one more time, and we are returned to the main display. So let's go ahead and plug it in now and see where we top off. I'm guessing it'll be somewhere in the mid 600s. All right, and there we are. We are right about 630 watts. So charging at this rate versus the 1350 or 1400 rate will allow you to maximize that service life just a little bit more. It probably doesn't make a significantly profound difference in service life, but every little bit helps. And if you're not in a hurry, why stress the cells more than you have to? You might as well charge at half speed. And talking about charging speeds, at full charge, it can charge in as little as 1.3 hours. And that's at full charge via AC, which is, again, maximum 1400 watts. Now, if you're charging this via solar, that's 2.2 hours if you max this out. And we actually saw that. In fact, I think we charged this faster than 2 hours earlier today. I'm pretty sure we were just under 2 hours. And then car recharge time is going to be more like 12 or 13 hours using the car charger, a standard 12-volt socket. And then if you combine AC and solar at the same time, which you can do, and it'll allow you to charge it up to, I believe it's 2200 watts. That would give you the ability to fully charge this AC and DC simultaneously in about 1 hour. And again, if we were knocking it down to slow charge via AC, that's probably going to take us about 2.5 hours approximately. So those are your recharge times. Okay, so pretty solid little unit with just a couple of minor compromises. One being during the solar recharging, where if you run it all the way down or let it go all the way to 0% state of charge, it will require you to manually plug in the solar connection after the sun is up to begin charging. And then the other one is while running full out at 2000 watts of continuous AC output, it did trip on me at the 8-minute mark instead of the getting through the whole 10 minutes without having to shut off. And I do hope you'll consider joining me for the next one. Until then,